Alright, so here we are. We're actually on the makeup video. This is just a quick one. It's not going to flow as well just because I kind of have to look all around the chart to find out what I missed. So we'll start off with the respiration. So aerobic respiration is oxygen is used, when oxygen is used, to convert glucose back into carbon dioxide and water. So yeah, if a plant was to do aerobic respiration, it'd need oxygen, versus an anaerobic respiration where the same kind of thing happens. It's in decomposers, and when they get the energy they need without using oxygen. So there's a variation between those two as well. Getting into what I missed on community and population, in previous classes we've all studied atoms and molecules and cells, as well as a little bit on organisms. After an organism, it becomes a population, so a group of organisms basically. Then there's a community, which is a group of populations basically that can potentially interact with each other. And up from there is an ecosystem, which is the same as a community, although there's an additional interaction between the non-living environment of matter and energy as well between them. Here's kind of the hardest part, which is the cycles. Basically, all three cycles I missed, they are as if they act as if the water cycle. They all move across the board. The nitrogen cycle consists of several major steps in nitrogen fixation, specialization, bacteria and soil, as well as blue algae, and in aquatic environments. Sorry, I messed it up there. But if we look at the chart, it's basically the whole cycle. That's the carbon cycle. Here we come over here, that's the nitrogen cycle. So yeah, basically nitrogen could be found in this water, it could be found in the soil, as well as with the other things. I mean, bear with me here. If you go to the next page, we talk about the phosphorus cycle. Everything in the phosphorus cycle contains phosphate, or is moving phosphate. And it circulates through ocean sediments and rock, and it's dissolved in water, and it all works in the same way, kind of as a water cycle, but it's just with phosphate. As well as the sulfur cycle. These all at one point are in the ground, decay, go up through the water, are in the atmosphere. It's just all across the board with these. We go in the coastal zone. That's what I missed in chapter 8. Coastal zone is a warm, nutrient-rich, shallow water that extends from high tide mark on land to the continental shelf. So you actually walk on the coastal zone when you're on the beach. Let me see what else I missed. Coastal wetlands, areas that are covered for all and/or majority of the year by the ocean. So when you see those waterways or the puddles, deep puddles there that kind of always have water. Very good intertidal zone. Ocean acidification is the increasing levels of acid in the world's ocean. Hence why you can see even in rainwater that the acid changes copper into the green. I mean, we saw that with statues that we did. Going into lakes, we missed lakes kind of, I guess, but oligotrophic lakes are lakes with small supplies of nutrients versus eutrophic lakes with large supplies of nutrients. There's cultural I don't know how to say this word, eutrophication, and it's when there's an excessive amount of nutrients that is actually in the lake. A mesotrophic lake is somewhere between both extremes, so it's basically in the middle. I mean, the majority of lakes are probably mesotrophic lakes. And there's inland wetlands as well versus the coastal wetlands, which anywhere that's covered with water for the majority of the year, that's not towards the ocean. So I think that's about all that I missed. If I missed anything, and or you have any more questions for me that you want me to do better or something, just let me know. I will not hesitate to come out here and make sure it's done right. So thank you very much, and have a good day.